Continue working on your scene from the last movie, or use the provided scene named cp06cars.max. In the last movie, you used Civil View's object placement tool to place objects in the form of lampposts, gantries, and signs. You now use similar methods to place animated vehicles that drive up and down the lanes. The process is not unlike constraining an object to a path, but as you will see, it is infinitely faster and easier. Make sure Civil View is initialized and select yet again the centerline alignment. Go to the Object Placement Style Editor, as you have learned before. Again, choose the private resource kit to pull content from. Also, as earlier, you are asked if you want to use the centerline alignment as a path. Choose Yes to dismiss the prompt. Add a new element, and make sure you are viewing the Vehicles tab. There are many to choose from. Start in the Cars subcategory, and make sure you are viewing the list in thumbnail form. The first car in the list, an Audi A3, is selected, and the system is by default set for a single entry. Set it to work in multiple random station mode, and set the number of cars to about 10 for now. Note the km/h field that you can set to define a speed for the moving cars. Set the speed to about 70 or 75 km/h for now. This means that if you were to apply the changes, you'd have 10 Audi A3s animated to travel down the center line. If 3ds Max needs to modify the end frame to accommodate the animation, it will display a prompt. Answer yes, and then scrub the animation to see the cars traveling at a constant speed. Of course, unless this bridge is meant to become Audi's own test track, it would be good to vary the vehicle types. Enable the Use Random Objects from the Selected Category option, and try again. You now have cars of various makes and types. Some may be very close or even overlapping one another. You'll fix that in a moment. For now, you need to offset them horizontally to ensure they're in the middle of a lane. For that, you need to calculate the distance from the center line to the middle point of a traveling lane. The inner shoulder is 0.9 meters. You need to add the distance that's equal to half a lane, or 3.6 meters divided by 2, 1.8 meters. The distance required therefore is 0.9 plus 1.8, that makes it 2.7 meters. The middle of the outer lane is a further 3.6 meters and a full 6.3 meters from the center line. You'll start with that one since you set up the speed of the cars to be a reasonable 75 km/h. However, consider what happens if you simply apply a horizontal offset of 6.3 meters. The cars are relocated to the outer lane all right, but if you were to select one and orbit around, you'll notice a gap between the tires and the road. This is because the road slopes down toward the outer gutter. Since you designed the slope to be mostly 2%, you can enter it as a decimal value in the crossfall entry. Enter minus 0.02, a negative value since the slope is angled down. This takes care of calculating the needed vertical offset, which in this case is about 12.5 centimeters. Apply again, and test one more time. This time, the tires should be quite flush with the asphalt. If you don't like the overall placement of the cars, you can randomize them again. For that, you need to make a slight change, such as enabling and then disabling one of the options. If you don't like a specific vehicle, maybe because of its color or simply because it is too close to another, then you can select it and change its parameters in Civil View Explorer. Make sure you do not close the Object Placement Style dialog, and call up the Civil View Explorer if you haven't done so already. There you can change the color, and the car's position on the path by specifying a different station value. In essence, the station value is the same as a path % travel. At the moment, all vehicles are traveling down this lane are family cars and compacts. To throw in a few trucks and SUVs, here's what you do. Bring down the number of cars to about 4 or 5, and then copy and paste the element. Base the duplicated element on SUVs and click Apply again to test the results. You need faster vehicles traveling on the inside lane. Select the Cars element and duplicate it again. Bring it down to the bottom of the list. Change the horizontal offset to 2.7 meters, which is the distance you need and that you calculated earlier. Note that changing the horizontal offset changes the other values as well. Again, ensure the crossfall is set to -0.02 and the vertical offset will automatically adjust. Because the left lane is usually the faster lane, set the speed to about 90 or 95 kilometers per hour. Click Apply to view the results. Scrub the animation and note how the cars traveling on the left overtake the ones traveling on the outer lane. Again, if some cars are too close together, you can adjust their station values. If a station value seems maximized, it's because the cars are on a loop and start again from the beginning. This doesn't prevent you from using the slider though, or simply from punching a new number. To create incoming traffic, it's an easy process that requires reversing a few values. Start by copying an element, let's say the fast-moving traffic you just created. You obviously need to inverse the horizontal offset to get the flow to the other side of the road. You also need to rotate the cars 180 degrees so that they are pointing the opposite way. Lastly, keep in mind that travel is based on a path and the direction of the path is currently left to right. This means that in order to have vehicles travel right to left, you also need to invert their speed. Apply the changes to test the results. Make the necessary minute adjustments to colors and positions as you see fit. Have a go at it and play with this for a while. When you're done, you can save your style, You can also import and try a style provided to you named mycars.ops. This style is very similar to what you just did. In addition, it has a few trucks, one bus, and a single ambulance added to the mix. Take a look, and again, make the necessary adjustments until you are happy with the results. Exit the dialog and save your file. In the next movie, you learn how to add your own custom objects to the Civil View library.